once I left the office hours this morning, I went in, it took me about 3 seconds to fix my stick program.
Oh, cool. Awesome. Better late than never.
Yeah, I just wanted to make sure it wasn't something that I didn't understand. I just wanted to make sure everything was on the internet.
Right, definitely. Yeah, this is a general observation on these programming assignments that I've mentioned to a few people one-on-one, but let me make some comments here. Right? I mean, we're in a college and we're here to learn. We're not writing, enterprise level software that's going to be deployed to do such and such and enhance customer satisfaction or something. We're trying to learn, right? That's our whole goal here. So part of that is programming assignments, and yeah, they get graded, and the grade is a percentage of your final course grade, and you need a C to move on and so on. But that's not really the point of these, right? It's not attempting to weed people out or rank people or anything like that. The programming problems are really learning exercises, and so they're designed to be something that for most people will be something you haven't already done, but something that should be within your reach, right, given sufficient time and energy, and that should go along with what we've been doing in class. And the primary goal is really that by the time you've finished PA2, you've learned something. Perhaps you learned how to make a perfect stick playing game, right? And if you did, that's super. But perhaps you figured out how to deal with argc argv, but you didn't quite figure out how to do the whole scanf thing, right? Or perhaps you figured out something better about using if statements or nesting if statements inside while loops, right? If you're learning from this is good, okay? If you get everything done and everything's perfect and everything's crystal clear, right, there is no higher level beyond that. But that's not the only measure of success here, right? The real goal is to be learning and building up your stockpile of knowledge, so that you can build on it for the next assignment, and then PA4 and then PA5, and so you can demonstrate that on the exams. But the goal of everything we're doing in fall is really to prepare you for winter, so that you have a tool set and you have recent programming experience, some of the tips and tricks and so on. And the whole goal of that is so that we can move on to object-oriented programming in spring, and use our firm understanding of algorithms to do more complex programs. And the goal of all of that is prepare you to move to a university where you're going to do even more complex things. So it's you want to try to do as much as you can on these assignments, but to the degree that you're learning something and you're able to do more at the end than you were at the beginning, right? Count this as a success. And so I went through and I played all the stick games yesterday, and I posted some feedback in Canvas. And by and large, the numeric grades were good. Lots of 80s and 90s, some 100s. And that's an easy way to look at it and say, hey, I think I did well on this assignment. But if your grade was on the lower end, or if you feel like breathing a sigh of relief that the code worked because you weren't sure it was going to work, or you got something in at the last minute but you have no idea why it works, right? Let's definitely let's talk in office hours and go through and just kind of work out those details, so that you have a nice solid footing at the end of PA2 to start stepping on to work to PA3 and so on and so forth, and also in preparation for the midterm, which we'll talk about a little more in a few minutes. But the midterm is going to be C programming and Bash programming, so that's a good thing to be up to speed on. So let me talk about some of the testing that I did for PA2. Give me a sec. So some of the things I checked. Oh yeah, go ahead and send me an attendance ping. Since people are pinging, send me a note. Let me know you're here. So some of the tests that I did. So I compiled your code, right? And then I ran it and I tried a few different things. So if you have more than one argument, that's an error. If you have an argument but it's not exactly an integer, that's an error. If you have an argument that's not anything at all like an integer, that's an error. If you have an argument that almost looks like a number but it's not an integer, that's an error. If you don't have any arguments, that's not an error. That says the user wants to specify the number of sticks at runtime, so you type in the number of sticks here. And if that's, something that's not an integer, if it's nothing at all, or if, it's a number that's too small, those are all errors. Any of those conditions, print a message, exit, you're done. But if you do specify a valid number of sticks, meaning exactly an integer and is at least 20, then you go ahead and you play the game. And so here are some of the things I tried. Well, I played with 20 sticks and I tried to win. And it should say that I won. And then I played with 20 sticks and I tried to lose. And every time the computer moves, it should leave me with a multiple of 4 sticks. That's how the computer ensures that it's going to win. And so I should lose in that case. And then I tried some bogus inputs. So if you don't type in anything, if you type aha, if you type something that's not an integer, something too small, something too large, it should just keep asking until you put in a valid number. And so those were basically the tests that I tried initially on your code. And if all of that worked flawlessly, that was probably as far as I tested it. If I got funny responses in some of this, then I started doing more testing. And tried to sort of pin down what was working, what wasn't working. And then I went into your code and I looked at the source code and kind of eyeballed it, made sure that you had commenting, you had indenting, you were using scanf instead of scanf, all this kind of stuff. And that was pretty much it. And then I posted a series of comments, sometimes with examples, sometimes without. But some of the main things that I bumped into. So the first thing was commenting. So if we look at this assignment. And we talked about this in class, and most people seem to pick up on it. But it basically says PA2 will be mostly the same behavior as PA1 with the following significant changes, right? So this is PA1, except, it's written in C, the computer goes first, the user may behave badly, etc., right? So I did not explicitly say in here, make sure you comment your code. But from this point forward, any course you take with me, where you're turning in code that I'm going to look at, it's got to be commented. Okay? ODPs are an exception because those get looked at by the computer, not me. But any of the programming assignments you turn in here, anything in 222, 223, any code you turn in CSE215, it's got to be commented. And the commenting needs to be throughout the code. And it should basically explain why you're doing what you're doing. If you say, count equals count plus 1, don't make a comment saying add 1 to count. Tell me why you're adding 1 to count. Keep track of the number of turns, right? Whatever. But always put comments in your code, put them throughout your code, but also put them in the beginning of your code, and make sure your comments include things like your name, the date, the course, the assignment, and a description of what the program is. And those should always go in, regardless of whether I say it explicitly or not. About half the submissions didn't have any name on them. And this is a work of authorship. This is something that you're writing. This is something that, in some cases you're spending many hours on. Definitely put your name in it. Get credit for it, right? It's like signing your name at the bottom of a painting or putting your name on the front of a story. So always put your name in your code, right? Whether or not the assignment explicitly says make sure you put your name in the beginning. So that was one thing, was commenting. Along the same lines, indenting. Make sure that you indent your code in some sort of consistent way. I'm not imposing a particular style, but any time that you nest your logic inside a function, inside an if statement, inside a loop, make sure you indent in some way to indicate that this is, inside something else and so on. I don't care how much you indent, if you use spaces or tabs, if you do it before or after a curly bracket, or that kind of thing. But start, make sure that you have a consistent style that makes sense to you, hopefully, and stick with that. Ooh, goodies. All right, let's see. So issues with initializing the number of sticks, this stuff up here, and issues with handling errors when you're playing the game, this stuff down here. Those are probably the most common sources of deductions. And in most cases it came down to using scanf instead of scanf, or not checking the return value from scanf, or in a few cases not checking argc before using argv. These things that we've been talking about around the ODPs. So if you lost points on that, or if you're not sure why what you did worked or something, let's talk about it. A few seg faults here and there. Make sure your code never generates seg faults. So I took off 10 points for a seg fault. A lot of courses, a seg fault gets you an automatic 0. If the TA is grading your program and it says segmentation fault and exits, a lot of times they just stop right there and record a 0. And keep in mind, when you get to a university, you may be taking a class with 80 students in it, and there may be a TA who's probably a grad student who's probably getting a few bucks an hour and has to grade, 80 programming assignments here, and then, 50 assignments for another course, in addition to working on their dissertation or their thesis, right? They're looking for a way to get through their work as quickly as possible. So if your code doesn't compile, if it generates a seg fault, if it doesn't run the way it's supposed to, they're probably going to write down a 0 and go on, because it's one less assignment for them to grade. So think of it in terms of that kind of level of harshness. I try not to be, super mean teacher in this course. So if I try to compile your code and it's got a compile error, I'll usually jump in and at least take a look. And it's really easy when you're adding comments at the end. If you're doing it, you put in your comments, and maybe the last thing you do before you submit is you put in a comment block at the top, and maybe you put an extra space in here. Maybe you said */. Well, your whole program is now a comment, and when I try to compile it, it'll say there's no main function, right? Well, I can find that pretty easily, and I can go ahead and remove this space, and now I can compile your code and test it. And yeah, I'll take off some points for not compiling, because that's something that you should check. But I'll still be able to grade your assignment, right? But don't rely on that, in the future, and particularly in future courses. So really make sure, whatever you submit, you're putting it in GitLab. Go ahead and pull it down afterwards, recompile it and rerun it, and do all of your tests. And you should probably, if you've been testing this as you're going, you should have a pretty good muscle memory of test cases to be using, and go through all of those on the code that you download again from Git. It's kind of a good final acid test. So make sure your code compiles. Make sure you don't get compile warnings. Now for this assignment, if you got like a single compile warning, I let you go. But if I got a whole page of warnings, that cost points. Warnings don't stop your program from executing, but that doesn't make them any less of an issue. So make sure your code has no warnings, no errors when you compile it. I think those are the main things. So if I left you a message saying, such and such, computer should go first, or many issues with getting number of sticks the user wants to take, right? And you're not sure what that deduction was, come by office hours and we can run through your code and see what it was doing at runtime, and then we can look at the source code and figure out how you could have done something differently. So any questions about that part of PA2? So let me just show you a sample source code. And as usual, you know, my standard disclaimer, this is not the only way to do this. This is not necessarily the best way. This is just one way that we could write this, just for comparison's sake, but also to illustrate with some specifics some of the ideas that we've been talking about. So you know, comment block in the beginning with some information. Function prototypes at the top that avoids some warnings. And then the main program with the argc and the argv, which is how we get command line arguments. If the person wants to say stick space 20, we can pick that up with here. All right, 3 lines of introduction. Welcome to the stick picking game, right? And then this init function that we talked about and I suggested might be useful. This does all of the work with figuring out how many sticks to play with. So if you say stick space 20, this will figure out you should play with 20 sticks. If you say stick space 20 space haha, this will figure out that there's an error. If you just say stick enter and it says how many sticks and you say 45, this will figure out you should play with 45 sticks. So this does all of the stuff that we've been playing with in ODPs and so on, basically parsing argc, argv and figuring out how many sticks to play with. And it just returns an integer. And that integer is one of 2 things. If there was any kind of error, it returns a 0. Otherwise, it returns the number of sticks you want to play with. So after I call init, I can say, hey, did anything go wrong? Did the user make a mistake? And if they did, I'll just return. You return from your main program, that's it, game's over, and we're done. If I don't return, then I get down here, and now we're ready to play the game. So I print out an initial stick pile. So print sticks, you know, prints the number of sticks. This is the number of sticks that were left in the game. Okay, that's always going to be the case. I set a flag playing equals 1 and I said while playing. I could have just said while 1 equals 1 or something, but I don't really use this anywhere. But here's the main loop. Okay, so this is the main gameplay. And it's the 2 steps that we've talked about, CPU move and a user move. So how's the CPU move work? Well, we call the CPU move function, tell it how many sticks we have to begin with. It tells me how many sticks to take. So I print a message saying how many sticks the computer's taking. This is a Kernighan and Ritchie trick for using a ternary operator. So I'm just, you know, if CPU takes is 1, this will print out computer takes 1 stick. If CPU takes is different from 1, this will say computer takes that number of sticks with an S at the end. So that's just a little trick you can use. But this basically says how many sticks the computer is going to take, which is, you know, whatever CPU takes is. And then subtract that from the stick pile, and then see if the game is over. If the number of sticks left is 0, the computer's won. It took the last stick, print out the message, and return. Otherwise, let's see what the stick pile looks like, and then let's do the user move. And the user move is almost exactly the same thing. Now I could have done it like, you know, user takes and so on, but I just did it right here. I said numsticks equals numsticks minus get move, because I don't have to tell the user how many sticks they themselves took. So get move figures out how many sticks the user wants, and that handles all of that detail. Asking the user, getting the input, parsing it, seeing if it's valid, retrying if it's not valid, retrying if that's not valid. All of that's inside this one function. And while I'm writing this main program, I'm not thinking at all about how I'm going to write get move. Here's what I'm thinking. I'm going to call get move. It's going to return a 1, 2, or a 3. That's all I got to know about get move. And so if this is the number of sticks the user takes, I'll just subtract that from my stick pile. If the number of sticks left is less than or equal to 0, I'll say you won and return. Otherwise, I'll print out the number of sticks, and I'll go back up to the CPU turn. And eventually you need to write these functions for printing the number of sticks, for getting the number of sticks the user wants, the number of sticks the computer wants, for parsing the command line arguments, right? But from a top level, this is my whole main program, and this is really the whole loop. So a little bit of intro, some setup to get the number of sticks, and then a main game loop. And then the rest of this is stuff we've already done in bits and pieces. So printing the number of sticks is just a for loop. Print out a pipe numsticks time, and then print out numsticks in parentheses. To get the user move, ask them a question: how many sticks do you want to take? Read the input using fgets, parse it using scanf, do the little parse trick with the extra thing, get the return value. If the return value is different from 1, meaning there was a syntax error, or if the return value was 1, meaning they did put in a number but the number is less than 1, or it's bigger than 3, they need to try again. So I'll say, how many sticks do you want? Get in a line of input, parse it, and I'll loop here until this condition is false, meaning that return value is 1 and number is bigger than or equal to 1 and number is less than or equal to 3. And then I'll return the number. CPU move is really straightforward. If this is the number of sticks, let's calculate that number mod 4. If that's equal to 0, I'll set it equal to 1 and I just return that number. And then this code we've seen a bunch of times already. This is the initialization. This is like our ODP from a few days ago. Get an argc, argv. If argc is bigger than 2, it's an error. Print a message and return. Return is 0, that's my flag to say, hey, something went wrong. And up here, when I come back from init, remember, I'm going to say if the value from init was 0, we're done. I'll just return from main. So, too many arguments, that's an error. If there's exactly one argument, they said stick space something, let's make sure that something's a legal integer. So convert it to an integer using scanf. If the return value from scanf is 1, meaning that there's no syntax error, and if the number is bigger than or equal to 20, then we've got a good answer from the user, we'll return that. Otherwise, something went wrong, return our error flag. Alright, one case left. Too many arguments, that's an error. Exactly one argument, do all of this. The only other option is there's no arguments. They just said stick, in which case, what do? Ask them how many sticks they want, do an fgets, do the scanf, check for the legality, and so the same thing that we did up here. So that's one approach to it. That's fairly modular, right? Lots of things broken up into sub-functions with the idea that when I'm writing my main program, I don't have to think about these details. When I'm computing how many sticks the computer's taking, I don't need to think about how I'm going to print that number out or how I'm going to decide if the game is over, right? That's being handled up here and down here. My CPU move has a single purpose. Given this many sticks in the game, how many sticks should the computer take? And as long as I'm clear in my mind, that's all that CPU move is doing, right? I can write it just thinking about that function, and then I can use it knowing that that's exactly what CPU move does. It takes the number of sticks in the game and it tells me how many sticks the computer wants to take. What do I do with that? Oh, I'm going to subtract it from the pile. What do I do after that? I want to see if the game's over. What do I do if the game's not over? I want to print what the pile looks like. Let's see, how efficient is printf is the chat question. If you had to print millions or billions of sticks, would looping with a for and printing still be the best option? Printf is pretty efficient. I mean, it's a heavyweight function because it can do a lot of formatting, but there's really no case where I mean, if you were going to print billions of sticks, you wouldn't be worried about the efficiency of printf. You'd be worried about, you know, how long it takes to send that information to standard out and display it. But yeah, nothing wrong with printf. It's almost never going to slow us down, other than the speed of printing. And you know, if well, this would be kind of fun. Let's try something. So let's add up a running sum of 1,000,000,000 integers. And we won't print anything until the very end. So there's our running sum. That wasn't too bad. I mean, it was a handful of seconds, but you know, it did it. There's a command called time that you can run that'll measure this for you. So it took 3.2 seconds of real time, that's wall clock time, and this is actual CPU time, and this is like overhead CPU time. So, you know, 3.2 seconds. Now, I'm pretty sure if we throw some prints in here, this will not finish. Right? And this is not, you know, that print F is taking a long time per se. It's that output to a screen takes a long time. And I'm pretty sure this will never come even close to finishing. So let's just do 100,000. Oh, 100,000 is not bad. So there's 10 million. Yeah, about the same. So yeah, not too bad. Maybe a 50x slowdown. Alright, that was a sidebar note.
It's showing a negative number.
Well, because my sum of that many integers will get bigger than 2 billion. And when
So
things
it's-
overflow, yeah.
Okay.
So if you go past 2 billion, it'll suddenly jump to negative 2 billion. So it's kind of
Is
random.
that just because the one would, I mean, it shows one where like a 2's complement means a negative number?
Yeah, so if we go 8-bit, this is 126. This is 127. That's negative 128. And this is negative 127, and so on.
Gotcha. Okay.
Alright, let's see. I prefer to concatenate my stick visual and bash before printing it because the alleviated fractions of time where only partial amount of sticks will be displayed. Didn't really have an easy option to concatenate characters. Okay, yeah, so just responding to that chat comment. Yeah, so string cat would be the way to do that. And that's a string function that will put two strings together. And there's a fair amount of overhead involved in doing that because, you know, you need to allocate space sometimes and so on. But for a reasonable sized game, I don't think we'd notice. Yeah, if you start getting too much into malloc in this course, you're definitely doing things harder than that. Concatenation is a fancy word for just putting two things together, usually two strings. So, you know, if you have like A, B, and C, D, and you want to put them together into a single string, A, B, C, D, that's called string concatenation. And the cat command in bash is called cat, which is short for concatenation. Concatenate files, because the way you can use cat is you can say cat and you can name multiple files and it will sort of put them all together one after the other and send that to standard out. But usually we just use cat for a single file. But that's the cat in that command. And for some reason every language has a different way to concatenate. Like sometimes it's a plus sign, sometimes it's a period, sometimes you have to call a function. Sometimes you just put things next to each other. It seems to be the thing where every language design team seems to think we're going to do concatenation our own way, and it's going to be cool. So that's always different.
Yeah, it's funny. I always thought that was just a visual display of the code. So if you put two files there, You said skip.c and then ODP4 and that, we put them together?
Yeah.
No, I didn't know that.
Yeah, so you can cat star.c and copy it into another file and stuff like that. Well, I don't know if I've ever done that. Maybe once in a while with cat, but almost always it's just displaying a single file. All right, let's see. Let's talk about the ODP. So ODP 413 is open. This will be a different kind of thing. So we're continuing with writing functions. So you're not going to print anything. You're not going to fgets anything. You're just writing a function. And the function here is called count e, and it counts the number of occurrences of the character e in a string. So it takes one argument, which is a char star, that's a string or an array of characters, and it returns an int. And the whole idea is if you say something like, integer num equals count e, quote, this is a test. This should set num equal to 1 because there's a single letter e inside this string. If you call count e on a, b, c, d, e, f, e, it should set the return value to 2. If you call count e on a, b, c, num should be 0 because there's no occurrences of the letter e. If you call count e with an empty string, it should return a 0 because there's no occurrences of the letter e in that empty string. Oh man, thank you. That is awesome. Thank you. Yay. I won't tell you what I got. All right, so you're going to count the number of occurrences of the letter e in this string. So this is the ODP, not PA3. So write a function, takes a character array, returns an integer. And you're going to want to test this on your own, so you're going to want to write a main program that does something like this, right? Call count e with a string, print out the return value. Call it with a different string, print out the return value. Or, maybe call it with argv bracket 1, so you can, test program space and just type something in, and so on. So however you want to write your main program, make sure you test this function. And then when you're done and you think it's working, go ahead and link it with the test bed and do the assess. And I think there's six tests that it runs it through. All right, so how do we do this? How do we process a string and look for occurrences of a character? So there's two things we have to be able to do. The first is, how many characters are there in the string? And the second is loop through those characters. And if your string bracket I, your string is just an array, so we can have an index I that goes through each of the characters in your array, your string, and if character I is equal to, and we're going to want a single quote e. Okay, single quote means a character, double quote means a string. Each element of this array is a character, so we want to compare it to a character, which would usually be an integer, or it would be a single quote character. And so if the string element I is equal to an e, we can increment a count. and make sure we initialize that count to 0. And then when we're done, we can just return count. And we got to initialize this so that we start off from 0. But because it's initialized, if we never loop through, if our string is empty, we won't do any of this. We'll just return count. Well, that's going to return a 0, which is the right thing to return. Or decrement. All right. So how do we loop through the characters? So anybody remember how to find how many characters are in a string?
You run it through character by character, much like you're doing looking for the E, except you look for the null character at the end.
Okay, so you can run it through character by character and look for the null terminator at the end. And if your string is, HELLO, the elements of the array will be HELLO and a null terminator. And if you make a loop and you start counting 1, 2, 3, 4, you'll see 5 characters. And it turns out there's a function that we can use to do that called string length. And that's exactly what that function does. So we can do it ourselves, but we're totally free to just use the string length function and basically calculates the length of the string, excluding the terminating null. If you're going to do this, make sure you include string.h. So that's where string length is prototyped. Excellent question here in chat. Could a string be created without a null terminator? So an array of characters could be created without a null terminator. Technically, we wouldn't call that a string, but it's just kind of a terminology thing. But you could have a string without a null terminator, but if you try to do pretty much anything with it, you're going to get into trouble. For example, the string length function looks for the null terminator, and so if we had a string that didn't have this \0 at the end, and string length started counting characters, it would probably count a bunch of extra characters until it happened to bump into a 0. And it might tell us this string has a length of, 73. So technically you could make an array of characters without a null terminator, but we would never do that on purpose. Can we do it accidentally? Absolutely. And that'll happen a lot. And that's a big source of issues when we start manipulating strings. We get a good chance to do that with the next ODP after this. Alright, so string length lets us know how long the string is. And so we could do something like this. So let's suppose we're writing our function and we're going to pass one argument to car star. I'm just going to call it str for string. So I can do the following. I'm going to call string length of str. I'm going to save that in an integer called len. And then I could do for I equals 0, I less than len, I plus plus. And to work with, character I of that, we just use str bracket I. So compare that with a double equal to a single quote e, and if it matches, then increment your counter. And this is a good point to revisit the idea of index origin. So very old languages like Fortran, they started counting elements of arrays from 1. Why? Because that's how people count, and people wrote Fortran. And so if you have 5 letters, you would call the elements of your array elements 1, 2, 3, 4, and 5. But that doesn't really work well for a lot of things. And if you sort of think about how a computer would probably count things, it tends to start from 0. So if we have, this string, and it's equal to, the string HELLO, this H is in string bracket 0, the E is in element 1, the two L's are in elements 2 and 3, and that last O is in element 4. Now the string length will be equal to 5, right? String length counts the number of the length of the string excluding the terminating null byte. So it's not going to include this, it's going to count 1, 2, 3, 4, 5 characters. But the thing to remember or write down or rediscover is that if string length is 5, the last index that we can safely use is 4. If we happen to try to index string with an index of 5, what does that do? Well, it just means we're going to look at the null terminator. But if we were trying to write our own function to calculate the length of this string and we accidentally went up to this null terminator, right, we could be off by 1. And there's always this plus or minus 1 issue with arrays and lengths versus indices. All right, let's see. What are some common languages where the index starts at 1 instead of 0? So mostly I think it's older languages. I know Fortran started with 1. I don't remember what Pascal did. I don't remember anything about arrays in COBOL. But APL, which is like a totally cool language, it actually let you choose. There's a variable called quad.io. And you could set that to 1 or 0 to change what the starting index for an array was. It was also a cool language because it has Greek letters and it has symbols like boxes, and boxes is a part of a variable name, but it had Greek letters for some built-in functions like iota and row and things like that. So if you wanna look at a language that will probably warp your thinking, take a look at APL. It's a sweet language. It stands for a programming language. No joke. Alright, that's my little APL pitch. Alright, let's see. Let me talk quickly about the midterm. So your midterm is on Friday, and a few things you need to know about this. First of all, the midterm starts at 11 o'clock on Friday. It's not something you can just do anytime you want on Friday. It happens during class time. So it's opens at 11 o'clock, and what will happen is at 11, under the midterm section on Canvas, you'll be able to download a PDF. It's the PDF that contains the midterm. And it will contain a number of questions, mostly programming questions. And what you need to do is answer the questions, write some code, whatever. You need to save your answers as a PDF file. And then you're going to upload that PDF file by the deadline. Now, the deadline on Canvas will say 11:50. If you have an extended time allowance, there's no indication of that on Canvas. Just turn it in before the extended deadline. Canvas will accept late submissions, but it will cost you 10 points per minute. So if Canvas says this was 15 seconds late, you're down 10 points already. If it says it's 5 minutes late, you're down 50 points. So two things. One, make sure you submit before the deadline. And two, submit along the way. When you finish a question, save it as a PDF, upload it. But this means that you need to make sure that you know how you're going to upload and how you're going to create your PDF file. So you want to practice this ahead of time, right? Whatever tool you're using, Notepad, Notepad++, Microsoft Word, which is really hard to get it to behave as far as formatting. If you're on Linux, not a problem. There's tons of tools out there. But you can sometimes export as a PDF. You can sometimes say print to a PDF file. But figure out what you're going to do ahead of time. You really don't want to spend 10 minutes trying to figure out during the exam, trying to figure out how to upload your answers. Do that ahead of time. Someone just said Google Docs lets you download as a PDF, and that's great. Just make sure that you can control the formatting so that if you try to indent with a tab, it doesn't do something weird like delete your entry or something, or change all of your I's to like uppercase or stuff like that. So practice this ahead of time. If you're not sure how to do this, come by office hours and we'll go through, you know, what your environment looks like, what system you're using, and we'll figure out some specifics. But do this like today, or, you know, come by office tomorrow morning and let's figure it out. You don't want that to be an issue during the exam. And you want to make sure that, you know, if you're, let's say you're going to use Notepad++, and you're going to print your output as a PDF, right? Make sure you know where that's going to get printed to. Where is that file going to be? Have that folder already open on your desktop. Make sure you know what the dialog is when you try to upload to Canvas. And maybe the first time that you do this, you know, it's going to make you hunt through your file explorer to find the folder, but maybe you can just drag it over, right? So plan ahead of time, right? Do not spend valuable exam time trying to figure out how to format your code or save as a PDF or where to find the PDF that you saved or things like that. Nail that down up front. And then the exam will be mostly programming questions. There might be some short answer, but it'll mostly be writing some code. Might be C, might be bash, might be a full function, might be a full program, might be a few lines of code. So I'll specify in the problems what I'm expecting you to turn in. Make sure you understand that. If I want 2 lines of code, don't write, you know, 50 lines of a main program and all of this. And I suggest you be in Zoom during the exam. Hop into Zoom, leave your microphone muted. I'll leave my microphone muted, but set it up to make noise if I talk or if I send a chat message out. Because sometimes, you know, I mess up on the exam, I have a problem and it doesn't specify everything you need to know. And if somebody tells me that, I'll announce, you know, clarification during the exam. If you're not logged into Zoom, I have no way to get that information to you. And you might spend, you know, 20 minutes trying to do something that can't be done. So plan on being in Zoom 11 o'clock on Friday during the exam. And if there's any questions during the exam, don't hesitate to just, you know, send me a note and say, hey, you know, what do you mean by this? Or if I do this, would that be a good enough answer? Or do you want something more? And you can just ask me. And worst case, I'll say, you know, I can't tell you that. You've got to figure that out. But if there's something that's not clearly worded right, I can give you guidance during the test. All right, send me an attendance ping, and that should do us for today. So we'll talk a little more about strings tomorrow, and then I want to talk about VI tomorrow and start looking at other ways we can use VI and be a little more efficient with that. So have a good one. I will either see you in 2:15 or I'll see you tomorrow.